Up next on my tiny bench is this beautiful Kenwood stereo integrated amplifier KA-3500. I believe it's from the mid-70s, about 40 watts per channel into 8 ohms, and this comes to me from the world's largest marketplace, eBay. And the seller acknowledged that power is on but does not pass the signal. First thing I'm going to do is pop the cover, take a look inside, see if there's any obvious signs of stress. And we will be right back. Just a real quick first look inside this Kenwood KA-3500. Thing that's obvious is how much dirt's inside the unit. I don't know if it's been sitting in a garage or a warehouse or something like that, but pretty dirty. Another thing that comes to mind is got some of that wonderful glue, and I don't know if that's a sign of distress there or if that's just the glue, but something doesn't quite look right around D5. So that'll be one of the first places I look. And I'll report back after I have a better sense of what's going on in this section. I decided before I did too much troubleshooting that I would clean out that board as best that I could. The way I like to do it when a board's that dirty, compressed air is not going to do anything to that because the dust and dirt was embedded. So I like to turn the amp sideways with the transformer on the bottom so that its weight is more distributed toward the bottom, and then spray it one time with quick drying isopropyl alcohol. Then I like to use one of these acid brushes, pretty cheap on Amazon, and just touch most of the components. Not talking about deep scrub, really just kind of agitating the dirt to get it to move. And then do another spray, knowing full well that we're not going to power this unit on for some time. It's going to need a bit to dry. So that's what I've done so far, and I find that it's just a lot easier to work on these if they're somewhat clean. Sometimes it's hard to detect defects and blemishes and things that are blown when they're coated in dirt. So that's what I've done with this one. Done my little alcohol bath. I'll check back in a bit. We'll see how much more scrubbing is needed after this alcohol runs off onto the towels and has an opportunity to evaporate. Thank you. Oh, I forgot to mention that another thing I always do when possible is just pull off that front panel and just protect that from anything that it might run into with getting thrown around on the bench. Moved around on the bench anyway. Back shortly. Wanted to do a brief update on the progress of the Kenwood KA-3500. As you can see, it is disassembled, and this is the main power board. This, in conjunction with this, serve as the preamp boards, and that's really what's required to get at the components that are on the power board, which I'll be talking about momentarily, and also to get at these pots and controls for cleaning purposes. What I will be doing, I'll clean all of these thoroughly with probably electrosolve, and then after that I'll treat the pots with Fader lube, and I'll treat the switches with regular deoxit D6, and then we'll test it pretty good again. For now though, I'm waiting on some parts in the driver preamp circuit, technically the limiter circuit. What had happened, we checked all of our power supply voltages, of course, and they all came in pretty tight, right where they needed to be, but couldn't develop workable bias across these emitter resistors. One side, the most it would develop was about 3.5 millivolts across these two resistors, and the other side was just flat out 0 no matter what we did. Now I could inject a signal, and the signal would pass through all the way to the output of the power amp, and in fact on the speaker terminals on the back of the unit, unloaded. But as soon as you attempted to put a load on, the dim bulb would glow and the voltage here, or the signal here, would fade to nothing. So the output signal on both channels would fade to nothing. So I have ordered these limiter transistors and these driver transistors and a couple of the electrolytics. And when they come in, I'll replace them. I didn't pull these to test them simply because I'd made a decision. I wanted to replace them anyway with something modern and quieter and perhaps a little more effective. So those are on order, as I mentioned, and I just didn't feel like pulling the transistor out, testing it, and if it's bad, leaving it out, if it's good, putting it back in, since my plan was to replace them anyway. What I want to do is I want to go one by one. I'll pull Q9, I'll replace it with a modern on-the-semi replacement, and I'll just make sure that I'm going lead for lead. So the emitter is where the emitter needs to be, base is where the base needs to be, the collector is where the collector needs to be. For me, I find it's a lot easier if I do that just one component at a time. And it's just a lot easier than if I just pull everything and then reinsert everything when it arrives. I just don't see any value in that. Also, I just don't want to tear up the board any more than I have to. So the plan is remove the item once, install the new item once, move on to the next one. Those probably be here in about a week or so, and so more about that later. What I've also done is I've cleaned up this board a little bit with good old-fashioned 99% isopropyl. It's not quite where I want it to be, but it's clean enough that I could inspect it. And what I will do after the new components arrive and are installed, I will do a final clean and just make sure she's spick and span, as good as I can get it. I took some pictures. I didn't take video, but I took some pictures of just how bad this looked before I did the preliminary cleaning. And I'll try and drop those in to the video so you guys can see what I'm talking about and what we had to clean up. That's where we are for now, and I'll report more as information becomes available. Thank you. Talk soon. Back with a brief update on the Kenwood KA-3500 Integrated amp. Really just wanted to show the cleanup we did on this chassis. It was pretty filthy earlier. And the technique is to use scoop. The one I use is sort of, I don't know what you'd call it. It's almost like a paste. Of course, I didn't discover this on my own. I heard of it from two of my favorite YouTubers, X-Ray Tony B, and I think Prime Hi-Fi was the other guy. Both excellent renovation or renovators of audio equipment. Of course, we largely just do repairs and cleanups here. We don't do the full-on renovation. As you can see, we've left these Elna caps in place. I did pull a couple and they tested fine. These are largely in low stress environments, so I left them in place. I did check the power supply caps. Those are fine as well. So I left those in place. I suspect these are not the originals. And just briefly, I'd mentioned before that I was ordering some of these transistors. Really just wanted to eliminate them as a possibility. I wanted to get some more modern transistors in place on certain aspects of the power board. Those did come in from DigiKey, got them in place. That enabled me to continue the troubleshooting, because really I just kind of wanted to eliminate those as a possibility. The problem, as I'd mentioned before, was that neither side would bias. One side was relative to zero, it was pretty much zero. The other side was just a few fractions of a millivolt above that. So since it was affecting both circuits, I suspected the problem was either the power supply or this muting circuit, which is kind of Kenwood's answer to protection, I suppose. The power supply checked out fine. Originally, that was the first thing we checked, of course. All those rail voltages were right in line with what we would expect. And that really left the muting circuit. It's called a muting circuit. I'll call it a protection circuit. I'll show a little bit more about it on a schematic shortly. But what it amounts to is you've got two transistors, two diodes, a capacitor, and then two resistors. What I was noticing when I was monitoring the voltages on several of these transistors, they were extremely high. For example, on Q9, can't seem to locate it right off, there it is. On Q9, the emitter voltage, or the voltage on the emitter, is supposed to be either 1.2 volts or minus 1.2 volts, I forget, but it was well over 25 volts. So that caused me to suspect something with that protection / muting circuit. I measured stuff in this area, and I was seeing diodes seem to have their expected 0.6 volt drop. Q26 showed 2 junctions. Q27 had some odd voltages around it, and I started wondering what was going on there. The resistors seemed fine, so I powered everything down, gave it a minute for a power supply to drain, and then I just checked with the diode mode of my benchtop digital multimeter, and the diodes seemed fine, 0.6 one way, overload the other way. The Q26 seemed fine. There were 2 junctions, one was 0.6, one was just under 0.7. Q27 had one good junction, but the other one looked a little wonky. Wasn't quite open, wasn't shorted, but it wasn't 0.6 either. So I pulled Q26 out of circuit, and I will show this on a schematic, and I checked it with the all component tester. I know those are much maligned, but they sure are handy and useful and pretty cheap, so may not be the end all, but certainly worth having one. And sure enough, it showed a problem with Q27. It didn't register as a transistor. It registered as two diodes, just not even related to each other to speak of. So I replaced Q27, came back on a dim bulb tester, no glow, checked for bias. I had turned these such that pretty much had turned the bias fully off, just these being the pots, the adjustments, variable resistors that control the bias across both emitter resistors. Turned those to where they would cut the bias all the way down. Came on with the dim bulb tester and measured across both at the same time, like I like to do, both emitter resistor pairs, and brought the bias up, and sure enough, it was coming up fine. So went off of the dim bulb onto straight wall power and turned it back on, and I was getting well over 40 millivolts, which is what the manufacturer calls for. So I brought it down to 40 millivolts. Actually, I brought it down to about 37 millivolts, and then I just let it cook for about 15 minutes, came back and checked it, and it had gone from 37 to about 42, 43 millivolts during that time. So I brought it back down to 40 millivolts, let it sit for a little longer, let it stabilize, and then tested it. And it tests fine, sounds good. I ran some preliminary power tests, and I think what I'll do for the next video is I will package this back up, put all the knobs on it, put the faceplate back on, and then I'll show the power capabilities of it. More with that soon. Thanks. We're back on the bench with the Kenwood KA-3500, and I thought I would do a brief clip to show how we set bias, and if time permitting, I might do a quick check on DC offset as well. You can see we are reading across the emitter resistors. Those are the emitter resistors that are tied to the power transistors, which are located here on the heat sink. As far as I know, those are the original power transistors. They're that Batwing or MT200 style, and hard to find anything in that style. I just didn't see any need to replace them, so I left them intact, left them in place. These emitter resistors are each 0.47 ohms, and what you do is you read from one side of one emitter resistor to the other side of the other emitter resistor. And I put these little dots on here to show me where my probes need to go, so I wouldn't have to try and memorize it or try and figure it out each time. Now, looking at the meters, what we're after here is 40 millivolts, and polarity doesn't really matter for this purpose. It's just the absolute value of 40. Amp's been on for about 15 minutes. What I'll probably do is set each one to close to 40 and then let it go another 15 minutes or so and just see if it's holding its value. So you see these little variable resistors here. There's one for each side. It's quite simply, you just adjust it. This time I'm using the right channel, get it close to 40. Then I like to go to the other side, get it close to 40. I say close to 40, I'm usually shooting for somewhere between 39 and 41 first blush. And then I go back to the other side and see what it's done. Is stabilized, is it up a little high? And bring it back down. And back and forth until you both are within that range. Close to 40 as you can get. I know there are a lot of theories about DC bias and where it should be set. Generally, I haven't seen a lot of comments about where the bias should be set for this particular unit, so we'll just go with what the manufacturer recommended. I know with some of the Pioneer stuff, there's a lot on the forums about alternate settings, and certainly that's worth exploring. Some great opinions on those forums. But I didn't see anything about altering the bias of this particular unit. It's a little high. I'm going to leave it there for a second. I'll come back to it in a bit after it has a chance to stabilize. Another thing that's always a concern with these older units in particular, but really any amplifier, transistor, solid state amplifier, is DC offset. And by DC offset, what we're referring to there simply is how much DC is on the output terminals feeding the speakers. And you don't want that to be too high because that can cause damage. So this meter here will be what we'll use to look at the DC offset. And I'm going to look internally here. These are the two output wires that go from the power amp board to the speaker terminals in the back. One yellow, one blue, and that's kind of the pattern throughout this unit. You see here are the inputs, yellow and blue, from the preamp to the power amp. So it's kind of sweet. So let's take a look at the yellow channel. Looks like it's about 43 millivolts. The blue channel looks like it's about 35 millivolts. Now on a modern amp, we'd want to tweak that down a lot closer to 0. This particular amp does not have a DC offset setting, so the way you achieve balance there is by matching the transistors throughout the circuit, primarily in the differential pair at the beginning, or the input to the power amp board. Basically Q1 and Q3, and then Q2 and Q4. Frankly, though, I'm going to call 40 millivolts close enough. It's not worth jimmying with, because it wouldn't likely be a noticeable difference between 40 and, say, 20, simply because of the age of the unit and the fact that there's no mechanism to speak of for just tweaking it, for changing it. I don't want to go in there and change values. I don't know that it's worth it to try and match transistors, because even if you match transistors, at this stage, some of the other circuitry could have drifted. So match transistors might give us, believe it or not, further variance or more of a DC offset. So we'll do some distortion measurements and power measurements. And if those are in order, and then later when we do the listening test, if that's in order, I think we're going to call it a day and not tweak with those. And also the bias, we're at 40.23, and we'll just have to see how that does when it stabilizes. I think I'll leave it alone for about 15 minutes or so, and as long as it hasn't drifted too much, I'll call that a day as well. And that's it for this segment. Be back soon. We're back on my tiny bench, looking at the numbers on the Kenwood KA-3500. start with, we are looking at the right channel, and clipping occurs at about 20.8 volts. This is a 40 watt rated amp, so we need to make at least 17.88 volts. Volts. And I'm going to bring it back down to 17.88 or so. That's close enough. And we'll take a look at the distortion numbers now. You see total harmonic distortion is 0.05. You see the big difference between the fundamental and the second harmonic. Got a little bit of noise here around 60 hertz. It could be fluorescent lights or any number of things. But that's the first test they want us to do. And since our spec is 0.2 and we're making 0.05, that one seems fine. I'm now going to take it down and we'll take a look at 1 watt. 1 watt into 8 ohms is 2.82 volts. I'm having trouble saying that word today for some reason, volts. Say it every day. Doesn't feel right. .82 is what we're after. I'm going to call that one close enough. Nice clean wave. And we are at 0.01. 0.01, 0.02 now. And again, you see a nice big drop off from the fundamental, which has the 1, to the second harmonic. It seems to be varying between 0.016 and 0.02. The spec is 0.06 at 1 watt. So well within specs. And we'll be right back with the other channel. We are now looking at the left channel of the Kenwood KA-3500 on my tiny bench. And I'm going to take a look at 1 watt into 8 ohms. 2.88 is close enough to 2.82. Good looking sine wave. And we are reading 0.018. And again, what we're 0.02, so it's varying a little bit. The magic number is 0.06, so we are well below that. And again, you can see that just really nice drop off from the fundamental to the harmonics. Okay. Next, let's take a look and see where clipping occurs. Well, there's 19.6, and there's 22, so it's between those two, well over the 40. And now I'm going to bring it back down to the 17.88. One of the problems with the detent volume control is it's hard to get right exactly where you want. 17.95, I'm going to call that close enough. And our total harmonic distortion is 0.041, evidenced by the nice drop-off. 0.041 at 40 watts, both channels driven. Well within specs. Back soon. Just playing some royalty-free music as a test. Right channel, both channels, left channel, bass down, bass up, bass in the middle, treble down, treble up, treble in the middle, loudness on, loudness off. A little more volume. Playing through some relatively low fidelity garage speakers. Back soon.